Hi everyone, welcome back. This is Unit 9, Lesson 5, and I know it's been a while since we've had a music video, so I have a special treat for you today.
The water in a beaker today. The ions broke apart in the usual way. The molecules of water kept the ions apart. A salt solution formed, but that's only the start. Homogeneous, the same throughout. Homogeneous, the same throughout. Solids that are polar can dissolve solutes that are polar or ionic. That is really cute. Water and non-polar solids just won't mix, but a non-polar solvent like benzene can't fix. Like dissolves light, polar and polar. Like dissolves light, non-polar and non-polar. And all the solvent molecules used up and expected the solute ion in your cup. Solution saturated in its full force. Yours saturation on the line. Saturation on the line. If there's still some water molecules unstuck, then we're solute with dissolve. Hey, you're in luck. Solution is unsaturated, can't you see? You're having gases of solubility. Unsaturated. Put more in. Unsaturated. Put more in. If you put more solute in, then you be dissolved. That is supersaturation situations involved. The X falls out as a precipitate, but the solution is unstable, so you hesitate. Supersaturation. Precipitate. Supersaturation. Precipitate. A salt is on the water in a beaker today. The ions broke apart in the usual way. It made it harder for the water to boil the freeze until the fusion temperature is a few degrees. The ligative properties. The ligative properties. Concentration. Electrolytes have a greater effect on the melting and boiling point of the solution than non-electrolytes. More solute that's dissolved got more effect. Solution's boiling point increases the red. The freezing point decreases, which is really nice. In the winter, salt on roads can prevent the ice. Add a solute, boiling point goes up. Add a solute, your point goes down. That is wicked cool. Solutions rule.
You're welcome for that. I think my favorite part is the bears. Polar and polar. That's super cute. So anyway, we're going to continue our discussion of ways that we express solution concentration. And so in our notes, I think we're on the molarity section of our notes, section 4. Right? That's where we are. So section 4 talks about ways that we can express how concentrated or how much of a solute dissolves in our solvent. And a new term for you is probably molarity. Molarity is abbreviated with a capital M, and the equation is given in table T to calculate molarity, and it's under the section called concentration, appropriately. And what molarity is equivalent to is the moles of solute. The solute is whatever we're dissolving, but it must be moles. Pay attention, it's moles. Because they're going to get wicked tricky on you, and they're going to give you grams instead of moles. You have to be smart enough to go, oh, I can't just plug in grams. I have to convert that to moles first. How do you convert grams to moles? Toward moles, divide by the formula mass, right? So we're going to take what we learned in the last unit and use it also here. It's the moles of solute per liters of solution. So two really common tricks that they do with molarity problems is they give you grams. You must convert it to moles first. And again, remember the way that you convert to moles is by dividing by the formula mass. The other thing they do is that they'll give you the volume of the solution in milliliters. And again, if they give you the volume in milliliters, you must convert it to liters first, okay? Whoops. And the way you convert from milliliters to liters is by dividing by 1,000, moving the decimal point 3 places to the left. Okay? So for example, if I gave you 560 milliliters of solution, that is the same as 0.560 liters. Okay? So watch for those little tricks as we walk through a couple practice problems together. Sample problem number 1. What is the molarity of a solution that contains 4 moles of NaOH in 0.5 liters of solution? So again, when we're doing problems that involve numbers, every time that we see a number, we put on the brakes, we write down what it is, and we identify it. So we are given 4.0 moles. MOL is the abbreviation for moles. Okay, so that's our moles of NaOH. That's our solute. That's what we're dissolving. We're also given 0.50 liters of solution. I don't see any other numbers in the problem. If there are no other numbers, you write down what the heck they want to know. What are they asking you for? What's the question? And the question comes right in the beginning. What is the molarity? So they're asking us for molarity. So then we would go to our reference tables and we would look up the equation for molarity. It's in table T. And molarity is equal to the moles of solute over the liters of solution. Once we have selected the equation we're going to use, we plug in. We have 4 moles in 0.05 liters. So we take 4 and we divide it by 0.05 and you should get 8. And 8 is our molarity. So we don't say 8 molarity though. We say 8 capital M. So 8 molar is our answer. And again, we write it 8 capital M, but the way that we say it is 8 molar. Kind of like the teeth, right? We have an 8 molar solution of NaOH. Okay, that is its concentration. That's twice as concentrated as a 4 molar solution, right? And it's half as concentrated as a 16 molar solution. So molar is our concentration or our molarity. All right, pretty straightforward. Look at sample problem number 2. What is the molarity of a solution containing 82 grams of calcium nitrate in 2 liters of solution? So again, when you see a number, stop, write it down. We are given, this time, 82 grams. Grams is not moles. Grams is mass. And we're also given 2 liters of solution. What are they asking us for? They're asking us for molarity, capital M. So we go to the reference tables and we write down the equation that we need. Molarity is moles of solute per liter of solution. Okay? Here's the problem I told you we were going to run into. They did not give us moles, but they gave us information to find moles. So before we can plug and chug, we have to convert our grams to moles. Okay? So we'll take our 82 grams of calcium nitrate and we're going to convert it to moles first so that we can plug it into that equation by dividing by the formula mass. And what that means is I need to get the formula mass for calcium nitrate. Remember how to get formula mass from the last chapter. You add up the masses of all the elements. So calcium's mass is 40. There are 2 nitrogens that are each 14. There are 6 oxygens that are each 16. So we can add those together to give us the formula mass. Okay, so this is going to be 40 plus 28 plus 96. And our formula mass is 156. So to get to moles, we're going to take 82 grams and divide it by our formula mass of 156. And that'll give us our moles. Remember, toward moles divide. You get 0.5, how many? We got 3. 0.53, we'll say, moles. Now we have our moles and we have our liters, we can go ahead and plug into molarity. Molarity equals moles, 0.53, divided by liters, which are 2. So 0.53 divided by 2 gives us our molarity of 0.27. I'm just putting my answer in sig figs, molar. Okay, again, you could leave it as moles per liter, or you can just write capital F. So this solution, because it has a lower molarity, is less concentrated than the first solution. And that's an important relationship you need to know. That the lower the molarity, the less concentrated the solution. Okay, so I think we'll leave it at that for today with molarity problems. We'll try some molarity problems tomorrow in class. And then our next video will be on other ways that we can express solution concentration. Have a great night, everybody. We'll see you in class tomorrow, and it will be Friday. Woo! Bye-bye.